Yes. Hi.
Okay, yeah. Apologies once again for technical issues, but we are here and that's good. So, yes, my name is Asada, and today I'm taking you through visualization and data exploration. And just a little bit about myself. Currently, I work as a data scientist with an insurance company in the US. But before then, I was in Ghana. I had my bachelor's at the Kwame Nkrumah University of Science and
As
Technology.
Hi, Asada.
Yes. Can you hear me? Hello?
Hi, Asada.
Loud and clear, loud and clear.
Yes, Teju.
Do you mind? Yes, and yes, I can. It seems you're not in the presentation mode right now for your slides.
Oh, okay.
Do you mind doing that and then maybe starting over so that we can cut the first part out and you can have a smooth one?
Okay, sure. Uh,
I think if you go to the slideshow, just to your right.
to my right. Oh, yeah.
Yeah, then click on the toggle down with the, yes, this is perfect. Thank you.
Okay. Okay, then let me hide you guys and myself so that I can see the full screen. Okay, sure. Okay, am I good to start?
Yes, yeah.
Okay. So welcome everyone to Visualization and Data Exploration. My name is Asada Adaidese, and I currently work as a data scientist with an insurance company based in the US. But before then, I was in Ghana. I had my bachelor's in computer science at the Kwame Nkrumah University of Science and Technology. And I went on to work a bit with Wave2 Analytics, which was involved in customer and retail analytics. Between finishing my bachelor's and working at Wave2, I joined PyLadies Ghana, which is a focus group under the Python Ghana community that tries to help more women become active participants and users of Python. So actually lead the data science focus group of that. Then also I got involved with Ghana Data Science Summit and Indaba X Ghana Deep Learning Indaba. So back in 2019, I happened to meet the Delali, Austin, and they were starting this out. So I came on board, joined the team, and then helped to pull off our first Indaba X Ghana. And since then, we've been having it almost every year. So I heard you guys talking about deep learning in Indaba. So actually my first deep learning in Indaba was in Nairobi in 2019. And I went there with Deborah. At that time, Deborah was the winner for our poster presentation here in Ghana. And I was representing the organizers in Ghana. So we went over there and then we saw women in machine learning and data science in Nairobi. And we're like, oh, we can have this in Ghana. So let's come back to Ghana and have that. So we started that also in 2020. And this year, we are excited that our number has grown. We've grown so much that we're able to host a Women DS session at the Indaba. So I also went on to have my master's in computer science at Stevens Institute of Technology in the US. And I took more of like data analytics electives. So after that, I got a job with Central Insurance. So that's just a little bit about me. So today we are going to look at why visualization matters. I'm going to make a case for why you should always visualize your data. And then the two use cases where we can use that, which is in data exploration, which we are going to go more into details about. But then for data storytelling and presentation, that's not the focus of our talk today. That's like a separate thing that you can also use visualization for, but I'll touch on that a bit. Then we'll look at the different data types we have and the types of visualization techniques we could use to display them, right? Or to help us understand our data better. Then we look at some visualization and presentation tools. And then I have the small like mini projects for you, which we'll discuss. And probably if the time is not enough, you would go back and look at it yourself and try to think through on how to like come up with data stories and all that. And I know you also have a practical workshop coming up. So probably this project and that will give you a more a good grasp on how to do the data visualization, and also some additional resources that I think you should look out for, especially on data storytelling, which is like another aspect of using visualization. So I'll go into why visualization matters. So I'm sure like me, most of you feel like in data science, like one of the most important things to do is building the models, right? That's like the cool thing. Personally, I used to think that, oh, just give me the data and let me start building models. And when you come from the environment where, I mean, all the toy data sets that we use in learning, machine learning, most of them are like well cleaned, well arranged, and for most of them, you can just go into machine learning, right? Because they are trying to teach you the machine learning. They probably don't go much into details as to how you clean, how you get it ready, how you like even try to have a whole overview of your data before you even come up with data stories or stories to tell about your data. But then in real life, I went into my job at Central Insurance and I realized that data is like so dirty. It's so different from the well cleaned up stuff that you get in school or when you're practicing or when you're taking tutorials and all that. In real life, data is really, really messy, and you want to really understand the data, do some visualization and then do some summary statistics as well as other things, right? So you have to get a good picture of the data to be sure that you are not coming with certain preconceived ideas and then trying to back that, but rather using the data to answer some of your questions. So in exploratory data analysis, some of the things you do are finding like the mean, the mode, the standard deviation, the skewness of the distribution of the data and all of that. And then probably go into do some small visualization and then go into model building. But I want to make a case for visualization that it's not just about the summary statistics. There was this man called Anscombe, and he came up with 4 different data sets, which is now called the Anscombe Quartet. And what he did was that even though he was able to generate 4 different data sets, right? But then they had the same mean, standard deviation, correlation, coefficient, like they had the same, they had the same descriptive statistics, right? The same summary statistics. So you'd be wondering, like, these are different data sets, but until you visualize them, you wouldn't see what kind of patterns or what kind of stories you can tell with them, right? So based on that, another guy called Albert Cairo, he came up with the Thesaurus data sets, right? So it's believed that the Anscombe's quartets, we don't really know how he created his data. So this influenced Albert Cairo, who came up with the Thesaurus data set. So when you see the table, the values, it looks normal, like normal numbers. And even when you look at the mean, standard deviation and all of those things, they look like normal values, right? But when you plot them, you actually see a dinosaur, and that was quite interesting. So you never know what could be hiding in your data, maybe, I don't know, a lion or something, right? So you visualize it, you wouldn't know a lot of what is going on in the data. So also based on the Thesaurus data, Autodesk Research came up with something called the Thesaurus dozen, where they use the same data that Albert Cairo came up with to make the dinosaur, but then they tweaked from the third to the sixth decimal points in the summary statistics we have over here, right? And they ended up creating different shapes. And this, like, if you round them to the nearest 2 decimal points, is the same mean, same standard deviation, same summary statistics, but we are seeing different things playing out here. So I hope this convinces you that it's very important to visualize your data, to just see everything as a whole, and like to have a wholesome perspective on your data even before you get into your machine learning and your model building stuff. So yeah, just to buttress the point that summary statistics helps to explore our data, but we can never trust it alone. We should always visualize our data. So as I mentioned, we are going to look at 2 use cases of data visualization. The first one is for exploratory data analysis. So most of the time, exploratory data analysis, as the name implies, we're trying to explore what's in the data, what's hidden in the data. So it helps us to answer questions with the data. For example, if you have a business problem, right, that you sell ice creams and you're just wondering on which days or in which seasons or times of the year are your ice creams more popular, you can, if you have data on that, you can actually find answers to that. That may be on Mondays or on the weekends or on hot days, you have the sale of ice cream going up. Also, exploratory data analysis helps us to explore what questions to ask in the data. Sometimes you might not know exactly what you are looking for. But when you are given, let's say, a COVID-19 data set, right? By just exploring, okay, maybe how many people caught the virus on this date or in which regions and all that, could help you come up with stories or with things that you can further investigate with the data. And it also helps us to discover the underlying structure of the data, as I mentioned earlier, and to find patterns, trends, anomalies in the data, and then know how to solve them. So for example, if you have anomalies in your data, you need to start thinking, okay, how am I going to deal with them? Because usually when you're modeling, when you're building your models, you're trying to come up with like an approximation of what the entire data set should look like, right? So if you have anomalies, how will you handle those? So EDA could be done separately or in conjunction with data cleaning, as we can see. And I should mention that it doesn't need to be like a shiny. So shiny meaning like it doesn't need to be perfect, like all the having your title, your axis labeled and all that, because usually it's for further exploration and it's just for internal use for you, the analyst or other analysts who will be looking at it. So the other use case is data presentation or like data storytelling. So in this case, you've finished with your EDA, you've done your model building, you have come up with your insights and you're trying to present it to the business people, right, or the stakeholders. So in this case, you're trying to distill some aspects of the data into easily understandable charts to convey insights, trying to convince them that your findings are true. And in this case, it needs to be visually appealing, right? So you shouldn't take a visualization straight from Python, Matplotlib, or from R and then just show it to like your business stakeholders. You want to make it more shiny. You want to take it through Power BI or Tableau. You want to have all your labels correct. You want to make sure your colors are all like obeying certain rules of visualization and all that. So I'll touch a bit on the visualization tools, some of them that we have, getting to the end. But I just wanted to state these 2 clear cases where visualization can be very important. So this aspect usually done with a presentation software or a dashboard, right? So presentation software like PowerPoint or like Keynote, or with dashboards from Tableau or Power BI, as I have mentioned. So this is an example of a Tableau dashboard for sales right, for sales performance for a certain product. So if you present this to like a CEO or the chief marketing officer, I know that they're able to tell that, okay, in the West, we are having a lot of sales, so maybe we should find out how we can maintain our lead over there. Or in the South, you're having less sales, so like what's happening? Should we go deep down and dig into why that's happening and all of that? And then see on the right, in the top right, you see the trend in sales, right? See that it's going up. So if maybe something happens and then we see that maybe in 2015 or so, it goes really, really low, like almost zero, that's like an anomaly, or that's like a strange case where we should investigate more to find out what's happening, right? So this is just a snapshot of what a shiny data presentation or dashboard looks like. So before we get into the techniques, right, I want us to briefly talk about the data types we have, because the kind of data you have will determine the kind of visualization you use. So even before we get there, are there any questions yet on what has been discussed before we get into that? Okay, seems there are no questions yet, so I will go on. Right, so we can look at our data. We can categorize our data into two groups. So the continuous, or like the numeric, and then also the categorical. So usually numbers. So like you can have the height of someone, temperature, like money, revenue, and all of that, and also text, right? The categorical aspect. So for example, like countries, name of countries, colors, and whatever other text that you have, right, that you might want to visualize. So I will go into the techniques. So first we have a histogram, and I'm sure we've all seen histograms before, right? At least, even if it's the first time you're doing data science, you've probably seen a histogram at one point in your life before. So when to use it when we're trying to visualize a single variable or a single data, a single variable, which is numerical, and then when we want to see the distribution, right, or the shape, how it looks when we plot it. So I want to quickly ask, can anyone give me examples of like a variable or data that you think we can use histograms to visualize?
Age distribution.
Sorry?
I said age distribution. You want to know the distribution of age range. Am I right?
Distribution of, I didn't get that. Okay. Okay, great. So like scores, right? So maybe you have a class of 100 students, you give them a test, and then you want to know, okay, how well did people do, right, on a graph, and then age as well. Maybe you have like for example, I work in insurance, so let's say age of drivers, right? You want to see the distribution of the age of your drivers in your like your policy holders, right? The distribution of their ages. Are we having more younger drivers or more older drivers? Okay, then yes. Okay, so those are great examples, right? Price of houses in the community over a period of time. Excellent. So you can tell, okay, are we having more pricey houses in this community or not, right? So yes, so there are different shapes. There are various shapes that can help us describe our data, and which we can help us to give us an idea of how our distribution is, right? To know what kind of questions to ask, right? That, okay, for example, are we having more expensive homes in this area, or are we having more younger drivers getting into accidents, like in terms of like insurance, right? And then know what to do from there. So you can visit, all the links are included, you can visit them to read more about histograms and then when to use them and how to use them. So also box plots used to show distribution of numeric data values, especially when you want to compare them between multiple groups. So for a box plot, right? A box plot helps us to, it's also kind of like the histogram in a way, because we spread like the data points to see the distribution, right? But the box plot goes ahead to help us find some of the stuff we'll find with summary statistics, right? Like the mean. So when we divide our data into 4 groups, right? Into 4 equal groups, and want to find the middle points. Once you find the middle points, like the middle point of the spread of our data, that's where the Q2 is, right? And then when we divide like the first part into 2, the first 25%, right? We want to see how many of our values fall within that range. That's the Q1. And then between the Q1 and the Q2, the next 25 is like how many of our values fall between that, and then so on and so forth, right? So you can tell that these other 2 blue points, they do not fall in our range that we are looking at. And since they don't fall in that range, those are considered as outliers, right? So if you have a data set with outliers, you have to start thinking of, okay, what do I do in the case of outliers? Do I want to drop them, or do I want to find a way to incorporate them in some way? So in our distribution, right? So looking at this middle diagram here, we can see that the box parts of the plot is like centered in the middle. So it gives us an idea of how symmetric our distribution is, right? Even though we have a little bit of outliers at the end, we see that most of the data is concentrated at the center point, right? So over here, the last diagram, we see that the box is like pushed to the left. So that's like skewed a bit to the left, right? Even though we have outliers over there. So it gives you a clear picture of the range of your variables, right? And if you have more than one variable, you'll be able to compare the 2 different pictures. Now let's look at scatter plots. So it's used when we have like usually pairs of numerical data, and then when trying to determine whether 2 variables are related. Whether 2 variables are related in one way or the other. So the example we have here is comparing the sale of ice cream versus the temperature outside, right? So over here, I think we have in the tropics, it can get very hot, but then it doesn't get too cold. But somewhere in like the temperate zones where there's winter and summer, winter, if you're in the ice cream business, it's probably going to go really low because people are feeling cold, they're trying to get warm and all that. So ice cream sales might not go that high. But then in cases where, or in the seasons where it's very hot, right? Sometimes there are even heat waves, and then they want people to like wear sunscreen and keep cool and all of that, right? People will be turning on their ACs, and people would want something chill to take. So having a data set like this and plotting it will help you to kind of like find how the 2 are related, right? So that if you have such a business, you can make more informed decisions as to even the stocking of your ingredients for the ice cream, right? To know when to do that, not to do it in the winter time too much, but then more in the summer to be able to boost or drive your sales. So I think, can someone give us an example, another example where we can use scatter plots for? Any thoughts? Or you're still thinking about it? Okay, umbrella sales and rainfall, that's a good one. Feature importance correlation. Okay. Can you give us like more, should I say like more practical examples, like with variables? Age of people and shows watched. Okay. Okay, I like that one. So remember we are trying to look at like two, let me see, sales in a year, price of house. Yes, that's a good one. Prices of house and average earnings, right? So if you have a data set like that, it could help you understand or help you find out that maybe those who earn more are buying the most expensive houses, right? And then those who earn less are not be buying such pricey houses. Okay, good examples. So the next one we're looking at is the line plots, and it's excellent for tracking changes over time. So if you remember the dashboard I showed you about the sales, you saw that at the top right corner, we're trying to track the sales over time, right? So this is like an exchange rate graph over time. So like from March 2019 to September 2020, like how the change in the exchange rate went over time. So any more examples? Any more examples that someone can give? Tracking changes over time. Migration, okay. Yeah, number of Ghanaian and Nigerian youth Japan over time from the 80s till date. I think that's a good example. If we have such a data set, it will be interesting to see. Okay, yes, time series, yes. Awesome. So the next is the bar charts, which is used when performing comparison of metrics values across different subgroups. So this is more for the categorical variables, right? So in this example, we're trying to find how many people or how many accounts are in, sorry, this are dollar values. So like how much money, for example, people are putting into check, into the average amount people are putting into check, into credit card, debit card, digital wallets, and cash, right? So does anyone have any examples? So you have a categorical value and they're trying to put them into buckets and then see which category has the most number. So average sales per month. Okay, if you're talking about the line graph, that's average sales. Okay, if you're talking about the line graph, right? That could be good. Or are you talking about like taking the year 2023, the average sales for the month? So yeah, I think average sales per month would be good for the line graph. But okay, attendance in the stadium, that is not bad if you have like different stadia and then you want to find maybe all the stadia in Nigeria, right? How many people are attending them? Wait, let me see. Okay, there's so many charts here. Let me try to read through most of them. Which brand of chocolate or confectionery sells per month? Okay, so instead of per month, right? So anytime you think of time, think of the line graph, right? Right now we're on the bar chart. So I think how we can, I think from Salam, how we can rephrase yours is, given the different brands of chocolates, right? The average sales of each brand of chocolate that we have. Let's say we have a chocolate company, right? We make different, like 3 different types of chocolates, right? So those 3 different types, let's say in the month of July, want to know how much sales we made, total sales we made, or average sales we made, right? And then amount exported by industry in a fiscal year. Okay, so it seems, I don't know if because we just switched from the line graph, which talks about time and year and all that. So it seems most of the examples you guys are given are based on time, right? So remember that maybe I should back up a bit. Maybe I should back up a bit and try to let you understand the difference. Okay, so anytime you think of something changing over a period of time, right? Like someone was saying, the price of chocolate over, like for different months or over a period of time, right? Then that's when the line graph comes in, because you are trying to track, okay, how much chocolate did we sell in January? How much did we sell in February, in March, in April, in May, right? That's like over time. But then when it comes to the bar charts, you're having different categories. So let's say we have, so using this example, right? We have data on the average amounts that Nigerians keep in these different buckets, whether cash, digital wallets, in their debit card, credit card, or checking accounts, right? How much people keep there on average. So in that case, you have like different buckets, and then we can plot. So when we plot, we see that, okay, a lot more money, people put a lot more money into their checking accounts than they have on them as cash. This is the difference clear? Number of sales for different, yes, exactly. So number of sales for different products. That's a classic example. Activities in a fun fair or park. Yes, so probably the number of activities. Like you have the different activities, and then maybe the number of people who patronize it, right? Say on the weekend or something, right? Let me see. So hope the difference is clear now, and we get the difference between the bar charts and the line graph. Average performance of students in grade 2. Unemployment rates by countries. Yes, so unemployment rates by countries is also a good one. But average performance of students in grade 2, so if you have, let's say, different grades, right? Let's say grade 1, grade 2, grade 3, grade 4, those are like categorical values, right? And then you have their average performances, then that's fine. Right. Okay, so I will move on to the next, which is the pie chart. So also used for categorical variables and used to show distributions of categories as part of a whole. So I'm sure you've all seen a pie chart before. So over here, 6% of total sales per market for small market sizes. So let's say you have a big company and you have regions. You have the West, the East, the South, and Central, right? So just looking at this pie chart, you can see that the West, you have more sales in the West and you have the least sales in the east. But for pie charts, you need to be very careful with pie charts. They are okay if you're using them in your EDA for your own personal analysis. But then in data presentation and data storytelling, it's advised that you avoid pie charts. In fact, one key rule of data presentation is that you try to use as less ink as possible. And as we can see, pie charts, we could have used a bar chart to show this same data, right? But then a pie chart is like taking a lot of ink on the screen. So we try to avoid it as much as possible, and also avoid all those like 3D pie charts and like that's all that is just like extra ink, which we want to avoid. So yeah, so these are some visualization and presentation tools. The good old Excel that we all know. You can do some graphing over there based on some table of data that we have. There's also Matplotlib, which is from Python, which you would go into later on. And there's ggplots from R. There is also Chat.js and D3 from the JavaScript libraries. And yeah, there's also Plotly from the Python libraries. And for the dashboarding tools, there's Tableau, which I've mentioned already, and Power BI, which is very, very powerful and can give you that kind of like good interface that you can present to business stakeholders. So for the presentation tools, as I mentioned, PowerPoint and Keynotes, this available on Apple, right? Where you put your findings and your insights into a good presentation to deliver to your business stakeholders. Okay. Okay, someone is asking a question, please. Why are we avoiding the ink? Shouldn't one tell a story, the results of your data, and make it pleasing? Okay, so there's this book, I've forgotten the name, but I can find it and put it on the Discord, that talks about like rules of visualization, right? So it's believed that the more ink you have, the more like you are covering up the insights. So it's like, just be concise and precise about the story you're telling, right? You don't need to add more ink on the page. So it's believed that like more ink would distract the viewer, right? So if there's a better way to display something or to tell a story, you go with that than to use a technique that uses more ink. So I will look for that book. I think it's like Elements of Good Visualization or something. I'll look for that and then put the link in the Discord for you to take a look at it. But generally, like all presentation experts and gurus, that's what they'll tell you, right? That there's a more efficient way to tell your story without a lot of ink. So someone is saying, what do I mean by ink? So what I mean by ink is like, you see the pie charts, we could have just represented that in the bar graph and it will still tell the same story, but having a whole circle and a whole sector talking about one thing that we know, right? That's what we mean by more ink on the page. So I think I didn't add the link to that book in the extra resources, but I'll put it on the page so I can read more about that, right? So please, I don't really understand what the box plot is used for. What can you use the information to do? Okay, let me go back. Let me go back to the box plots. Right. So did you understand the histograms. Okay, so the histogram helps us find the distribution, right? So it's similar actually, right? So if you look to the right here, we have a histogram and then a box plot down here. So in this first one, we have a symmetric distribution where most of the data is found in the middle, right, in the center. And you can see it's replicated in the box plots down here, right? So this box here shows us it shows us where most of the data is, and then the midpoint, right? The midpoints of the data. So if you have a lot of variables that you want to compare, you might not want to have a lot of histograms showing, right? So the box plot is like a quick way to kind of still view the distribution. Okay, it's kind of like a quick way to kind of still view the distribution. And over here, the Q1 is just showing us where the like the first 1/4, most like where 1/4 of your data, right, in the lower part of your distribution lies, right? So this 25% up to the Q1, it shows how much of your data lies in the 1/4 like lower quadrant, right? And then this from the Q3 to the end shows the opposite side, right, on the higher end, right? So you can see that it lines up with the edges of these boxes, right? So even though the histogram will just show you the distribution, the box plot kind of goes in depth to make you see where the middle part of your data is, where the most part of your data lies, which is between where the most part of your data lies, which is between the Q1 and the Q3, right? And then you're able to see the outliers also at the end. So if you can't have like a lot of histograms on your page when you want to compare different variables, but when you have box plots, it makes it more concise. And just looking at it, you can see that, okay, most of my data is in this part, and then, but I still have, the line shows that, okay, we still have some data there. And then this vertical line shows that this is like the endpoints for your distribution. And then on the right side, this vertical line shows that this is the endpoints, right, of most of your distribution, but you still have like one outlier out here. Sorry, one outlier out here on the end, right? And in this picture, we can see the skewness that most of your data is like towards the left side, even though you have some outliers on the end, on the right side. I don't know if this is clear or there's any further question on that. Okay. So I think other data. Please, what do you mean by other data will not be used? You mean the outliers? Is there a way, can people unmute and speak? Maybe that would be better. The one in light blue. Is it possible for people to unmute and speak? Maybe that would be like faster or something.
Okay, I'm saying the ones on light blue, wouldn't it be used now that you know where your data lies? How about the ones in light blue?
Yes, so this is exploratory data analysis, right? So that if we hadn't plotted this, we wouldn't easily see that we are having outliers which fall far outside the range we are looking at, right? So this will kind of probe more questions that, okay, what are those outliers? What do they mean? So you can probe further to go and look at, okay, what are they representing, right? And then even why are they there? And if you're going to build any model or something, then you know how to deal with that, right? So, I mean, visualization is supposed to bring out the insights in the data. So when you're able to see that, okay, you have outliers, then you decide on what to do based on the business problem you are trying to solve. Does that answer your question? So let me see if I can get an example. So for example, let's say age. Okay, let me still use the insurance example. So we have personal auto insurance policies where we have information on drivers, the kind of cars they drive, their ages, and all of that stuff, right? So if I want to have a box plot showing the distribution of drivers' ages, right? And let's say on the far right, I have these outliers. So I go to check that what values are they? And then I see maybe 100 years or 108, right? Good. So someone is just mentioning the points that I'm about to make. So 100, 108, probably it's an error because like someone 100-year-old, I don't know how 100-year-old would drive. In the US, healthcare is great. So people even 80 years old can drive, but like 100, that's crazy. So I'll go and check like what's happening. Probably they're supposed to be out of the data. Probably they died or they are not with us. They are not policyholders anymore, but probably we still have their data, which is still counting their age, right? From their date of birth. So I realized that, okay, I don't need these people, so I can take them out. In that case, do you get it? So it could possibly be an error. So I can take it out. Or let's say it could indicate that there's more like there's further things I need to do with the data, right? And then I'll decide whether I want to include it or not, which in this example, I'd want to include it because probably in my analysis or in my investigation, I realized that they're actually like dead or they are not policyholders anymore, right? So that's what data visualization does. It kind of like shows you what you have and then you know where to go to or what to investigate. Okay, is that clear?
Yeah, please. Apart from the outline, I mean, from that other 25% to Q1, before Q1, and before Q1, the blue line before Q1. If you want to analyze it, do you mean that you would only focus between Q1 and Q3? Is that what the box plot is telling you to do? As in, now that you know the distribution, you know where your main data are. The remaining, the data before Q1. Would you not stop concentrating on them, or what would the information help you to achieve now? Apart from the outlier at the other end, the data before Q1, what would you do with it now that you know the information?
Yes. So let's say you're still using the age example, right? Let's say that this is the ages and maybe the Q1, the point here is maybe 18 years old, right? So, okay, let's say 30 years old. So it will show you that you have about 1/4 of your policyholders being below that age. Do you get that? So it's just let you know that, okay, if I want to do something targeted at a particular age group, right, I have like 1/4 of my policyholders falling below that. And so what do I want to do with that? Then you don't want to answer your own question that, okay, so this is the like number of people or the group of people falling within that range. I don't know if it's clear. Yes, okay. So I think we got to the questions part. So I think we can keep the questions coming in for now. Yes. Okay. Any more questions? Okay, so I put a link to the starter notebook, which is not complete. Yes, right. And then also to the final notebook as well in the drive. So you can take a look at that. So I know you're going to have a lab, like an actual hands-on lab on this. So I'm just going to go over a few things you can do in your EDA, the kind of questions you can ask. And then later on, you can try your hands at all those things, right? And then also think of more questions that you could ask with the data. So, before that, you see that I've linked some additional resources in there. So this first link goes to a data camp course, which is very good. It gives you like more understanding on the data types, the kind of plots you should use for what cases you have and all that. And then also this the course I was talking about, data storytelling. It's actually a paid course. It's taught by an ex-Google data evangelist, and it was a good one. I really enjoyed it, and it talked more about finding data stories and then how to present the data to your audience or to the business stakeholders in order to make impact. So that's also a good one you can look at. Okay, someone's asking for me to send the links there. So I will put the link in the chat. And then also the notebook. Okay. I think I put it in the Discord yesterday. I think they're not allowing me to. I don't know why. It's not allowing me to just. Oh, I was clicking save as. Okay, copy. Yeah. Okay, so also don't forget the link to the feedback form, which I saw was put in the chats, right? It's also right here in the slides. So I'm going to switch over to the notebook briefly. Yes, the less ink resource. Yes, I'll do that. Let me note that. So I think I will give like a 5 minutes break. I'll give like a 5 minutes break before we get into the notebook. Okay, so we are back. If you are back, let me see your thumbs up in the chat or your emojis. Okay, great. So I'm going back to share my screen. Okay, great. Hope you can see my screen. So this is an interesting project I found on DataCamp. DataCamp has some really good courses and projects which I recommend. Also, their data science courses and projects I've looked at are very good, so you can look at them. So this is about the Google Play Store apps and reviews. So I'll try to use like the next 10 minutes to go through, and then I'll leave the rest to you to think about. And then also after your lab session, you can come back to it to see if you can do stuff on your own as well with it. So we all know the Google Play Store, right? So mobile apps are everywhere. They're easy to create, blah, blah, blah. We all know about mobile apps. And we've been given some 2 data sets to look at. So we'll look, says that in this notebook, we'll do a comprehensive analysis on the Android app market by comparing over 10,000 apps in Google Play across different categories. And we'll look for insights in the data to devise strategies to drive growth and retention. So there are 2 files. There's the apps.csv, which contains all the details of the applications on Google Play, and it has 13 features or 13 variables that describe the given app. And then there's also the user reviews, and the user reviews contain 100 reviews of each app. And the text in each review has been pre-processed and attributed with 3 new features. That's a sentiment. So whether the review was a positive review, a negative review, or a neutral one, right? Then sentiment, polarity, and then the subjectivity of the sentiment. So first of all, open them in Excel. Can you see my Excel screen? I doubt. Oh, you can't hear me? Hello? You can hear me. Is it loud enough?
If you are audible enough, I can hear you. Probably from that side.
Okay, can you see an Excel screen? Let me see.
No.
Okay, it's just the Google Play. Okay, let me reshare. Okay, so this is the apps.csv. And our good old Excel, right? So there's this column here that I guess we're just using to number the columns. But then the most important ones are the app, the name of the app. I don't know if you recognize any app that you know over here, right? And then we have the category, the ratings. So we know that ratings is on a scale of 1 to 5, right? The reviews. So these are like IDs to the reviews. And then the size of the app, I think in megabytes. Yes. The number of installs, the type, whether it's free or paid, the price, the content rating, the genre, as in like the theme of it. And then when it was last updated and the current version. And then like the Android version it is, right? So I want us to have a little interactive session here. So based on the graphs and the charts and stuff we've made, right? And we're trying to remember the question is that we're trying to look for insights in the data to devise some strategies to drive growth and retention, right? So what are some of the questions we can ask, even just based on this sheet, based on this CSV file? I think you can unmute and speak so that I don't need to be going in between the chats and back. Oh, okay, you can put your hand up, I guess. Yeah, you can put your hand up.
Yeah, sorry.
So you want to say something?
Yeah, I wanted to say something.
Okay,
So,
sure.
like, from the data set, I think we can ask like, what's the correlation between the rating of each of the app and like the number of installations? Like, how does the installation, like number of installations that has been carried out on the app affect the rating of the app? So you can do a plot of those two attributes and see like how they relate to each other. That's the idea.
Sorry, can you come again? You said the correlation between what?
Correlation between like the number of times the application has been installed and the rating. Sorry, can you hear me?
Yes.
Okay, I said from the data we can actually ask a question of how like the number of times the application has been installed affects the rating of the application. Hello?
Yes. Yes, that's a
Can you hear
good one.
me?
Yes, I
Okay.
did. So correlation between number of installs and ratings, right? That's what you said, right?
Yes, that's what I said.
Okay, great. So I'm taking notes of all that here. So maybe I should let me share. Yeah, maybe I should share the whole screen so that you see this. Can you see the notepad? Okay, that's a good one. So correlation between the number of installs and the ratings, right? So maybe the number of installs and then the number of 5-star ratings or 4-star ratings, right? Okay, so anyone else? Let's try to like bring out the data stories or like the kind of insights that we can gain from all this. So if you have the link, you can open up the sheet yourself and have a look at it, right? So anyone else, you can put a thumbs up, or you can put up your hand and I'll call you to speak. Okay, Charles. But before Charles comes, let me I realized I didn't open the reviews for you to see. So you have the reviews, the text, some text in there stating the reviews, the sentiments and all of that stuff, right? So yes. Charles, you can speak.
Okay. I think we can check the relationship between the price and the installs.
Good, that's a good one. So wait, I think okay. Relationship between let's all take notes of this. Okay, this is the interactive part. Let's all take notes of this, because after this I'll let you go back and we're all going to think through the kind of visualizations we can use, and then you go back and try this after your labs. So Charles, could you please come again? Relationship between the price and number of installs, right?
Yes.
Okay. Okay. So who else? Elijah.
Yeah, I think relationship between reviews and rating.
The word and rating.
Yeah, the reviews, like the number of reviews you're having with the ratings.
Okay.
Reviews and rating.
Okay, so I think nobody is really, I haven't so far, I'm hearing like comparing two different variables, but let's start from the basics, right? Who wants to know what's the most expensive app costs, right? The max cost of any app at all, or the number of apps in each category, right? Okay, maybe that's someone's, let me not say it, maybe that's what that's what Elijah is going to say, so let me not say it.
Yeah, we can also explore like the most, like the genres that like the public are more interested in, or the categories that they are more interested in, by finding the sequences of each of
so the most popular categories, right? Can you come again? The most popular categories.
Yes, like the categories that interest, like the most popular categories.
Okay, the most interesting and most popular. Okay, great. So Elijah's hand is up. Elijah. Yes, Elijah, you can go ahead and speak. Oh, his hand is down. Anyone else? Kindly raise your hand or unmute and speak so that I don't need to go into the chats. Okay, someone said the most downloaded and least downloaded app in each category. Okay, that's a good one. Let me put it up here. Anyone else? There's a whole lot.
Sorry. Yeah. We can examine like the distributions of the numerical series from like the rating, review, the price. You can just like examine the distribution of like those the features that have like a numerical data type. You can examine like that distribution to just see how like the range from it.
Yes, that's a good one. So for example, like the ratings, right? So like how many, we can look at distribution of how many apps have like 4-star, 5-star, 1-star, 2 stars, right? We can look at all those distributions, and we can put them on box plots, since they're like different variables, right? Instead of just using one histogram for a particular variable, we can look at all of them as well. So yeah, that's a good one. Any other hand up? Okay. Chinelo Okafor. Yes. You can go ahead, please.
We can look at the months with the highest download.
Great. Apps with the most downloads and also the least downloads, right? And also for each category.
Okay, I say the month, as in the month that we have the highest download month. The month.
Okay, so we have we actually have some dates. So the dates we have is the last updated. So I don't know if you realize, but when you go to the App Store, the Play Store, you see the dates for the last updated, right? So you mean the apps with the most the months, or the app with, I don't know how to frame the question. So, okay, based on these dates that we have, can you reframe your question or your statement that you want to find out?
Okay, I mean, as in the in every month, okay, there are different apps, right? So okay, yeah, I understand what you're saying now. So probably the month that apps are mostly downloaded.
Okay, okay.
And any app of any type, but the particular month that we have highest, is it in Christmas time? Is it New Year? Do you understand? Yeah.
Yes, that's a great question. The only thing is that we don't have data back in that, right? We don't have dates showing us like
We actually have like data, but we just have to like extract like the month from each of the dates. You can possibly put it in a new column, then from there we can get that.
okay. Ayodeji, are you talking about using this variable, the last updated?
Yes. You can just, I think, like from what she said, you can just extract like the month for each of like the data points. Like the first one is 7th of January, and that will be January. This one also, next one January. So like that we can explore like in what month we have like.
Yes, so we can actually do that, right? But thinking about it, this is when the app was last updated, not necessarily when somebody installed it. You get it? So each variable is talking about a particular app and details on the app. Sorry, each row is talking about a particular app and the data on it, or the variables for it. Each row is not talking about a user's download of the app with the days they downloaded. Do you get what I mean?
Yes.
So this is like the last updates for the app, not necessarily when someone downloaded the app. So that's actually a great question to explore. But in this case, we don't have data to back that. Do you get what I mean by we don't have data to back that? We don't have yes. If we had a table where each row signified maybe user 1, and then they downloaded the app on this date, user 2, they downloaded on that date, then we can aggregate stuff and see that, okay, all these users downloaded the app in the month of January 2018 or not. Do you get this point?
Yeah.
Okay, sure. But that's a good question to explore if we had that data. Yes, so I think I saw another hand up. Elijah.
I want to ask, I don't know whether there is a feature that has to do with contain ads, like adverts, because I know a lot of people don't like adverts in their app applications. So is there any of the features that add maybe include maybe containing ads? And let's see, maybe we can relate that to how the number of downloads, because some people don't like ads app. So I don't know whether the feature is in this data. I'm not sure whether it's there, like to tell us that this app contains ads or not. I don't know whether it's on this.
Yes. So actually, we don't have that, but I like the questions you're all raising, right? Where we realize that we don't have data for that. So actually, like in the whole data story process, you realize that here we are doing, it's more like a tutorial and the data has been prepared for us, right? And they've given us specific variables to use. But in the real world, let's say you work at Google and you're working on the Play Store, right? And you realize that you don't have data on the number of ads that it shows or whether it displays ads or not, then you can go back to look for more data to come and use, right, to answer your questions. Okay, so in the real world, when you discover that there are certain questions you want to ask, but you don't have data that can help you to answer, then you go back to the stakeholders or whoever is involved with that kind of data and see if you can actually get that data to come and use and bring out all these stories, right? So it's not just the data are given, you can also look at external data as well, if it's available, right? You can also look at external data. So a classic example in like the work I do in insurance, apart from asking people for, let's say, home insurance, right? Apart from asking, okay, how old is your house? What material do you use to build? Do you have a dog or not? Apart from asking all those questions and using that data, we also realized that in the US, some places they have hail, right? The weather conditions can destroy your roof. So we actually have this variable called roof score, which is from a company called Verisk. So they take pictures of people's roofs, like with satellites, and they're able to classify them into whether it's a good roof or bad roof based on a certain score they give. So my company will not be able to come up with that data. So we realized that it's an important variable we need. So we go to pay for it from Verisk, which is a provider, right? And they give us those scores, which we also use in our models. So this is a classic example. I like the way the questions are coming, like you guys are thinking of questions we can ask for which you don't have data for. So in a real world situation, you go out there and see what additional data you can add to be able to solve your problem. Okay, Elijah, I kept you waiting for long.
Yeah, I'm okay. I'm fine. I think you responded well. Thank you, Ma.
Okay, sure, great. So I think our time is like almost up or something. So let me quickly like round up. The notebook is available. So I want you to think of graphs, the type of graphs that you can use, right, to answer these questions. So we saw that correlation stuff was more of the scatter plots, right? Scatter plots of if we have two numeric variables and want to see what kind of relationship they might have, we can visualize them with the scatter plots, right? And then finding the most popular categories, we could use the bar charts so that we see the tallest charts, right, among different categories. The most downloaded or the least downloaded app as well can be found. We can see it with that, right? Even the pie charts could help us to see that also in a way, right? And I think that's the question that Chinelo asked about finding how many apps were downloaded at a particular time in the day, or like in a particular month of the year. That one would have been best done on a line graph, right? To show us like which months are giving us the most downloads and all of that, right? For maybe a particular app or for a certain select number of apps, or even for a category of apps, right? So the notebook is available. It has like all the instructions to go through. I know you've done a little bit of Python, a little bit of NumPy, probably a little bit of Pandas. But I know that in your hands-on session, you're going to do more, like you're going to get more of the practical skills, as in like the code to type. So this is a very interesting problem. I'm sure you can all tell that it's a very interesting problem to solve. So I'm going to leave that to you to kind of like read through and then still continue thinking through the kind of questions you can ask, the kind of graphs you can come up with, right? And even in EDA, so there's a whole lot with EDA. I didn't mention that there's a whole, like you have to do data cleaning in case you have duplicates, how you drop them, in case you have missing values, how you would deal with them, in case you have certain let's say certain data types are not right. For example, the price of an app, right? In order to do computations with it, it has to be in a float or in a decimal data type. But if it's in like a string or in a text format, you might not be able to do much with it. So how to even transform or convert the data type to the right data type that you need. So when you go through, I know that your hands-on session will go in depth into some of these things, right? So after you do that, you can come back to this and ask more questions and do more, try out the visualizations that we've looked at. And then also the extra questions you have that we don't have data on, you can also search online to see if you can find that data. So there are places, there are sites that have some data sets like Kaggle, Zindi and all that. So you could also, if you're interested in this particular program or this particular project, you can further look into that, into maybe how, if Google makes that data available somewhere through an API or something, how you can also incorporate it into your data and all that. So this was just an overview. This is just an overview of like the whole, where visualization comes in, how or why you need to look at your data visually and not just depend on the mean, mode, and the statistical, the summary statistics, right? And all of that. And then also how to ask data story questions and how to answer them. So this was an overview. When you get your practical tools, like when you get the practical skills ready, you'll be ready to come back here and come and apply all that knowledge to solving some of these questions or answering some of these questions. Okay, so can I please include the questions in the folder? Okay, sure. Is it the questions I put up here? Okay, sure. I'll do that. I'll do that so that when you further, when you're reviewing it and trying to remember the questions that people asked in class, you would see it. So, yeah, any other questions? Any other questions before we wrap up? No, time is fast spent. Okay, so if there's another question, please remember the feedback form, and then also your attendance form as well. I hope you like this session, and let me know if you have any further questions in the Discord chat. I know I'm supposed to give you information about the visualization, the ink stuff, right? And then also these questions. So let's talk more on the Discord channel. If you have any questions, let me know and I'll do well to answer them. So yes, thank you for your attention.
Wow, thank you so much, Ase.